Okay, let's get this started. 7 o'clock. Thank you, everybody, for attending. I'm Sammy from Seaborn Organics. We're an organic fertilizer company based in Southern Ontario here in Niagara region in St. Catharines. And we specialize in a very unique product. It's a squid-based fertilizer that we repurpose from the leftover squid from calamari consumption. And I'm very excited to introduce Dr. Singh. He is a force in agriculture and at the top of his field for regenerative and organic agronomists. So Av is a longtime member of the Canadian Organic Growers and National Farmers Union, as well as Vice President of Regeneration Canada. Av is also a faculty member at Navdanya in India, where he delivers courses on agroecology and organic farming. So we're really happy to have him here and speaking about our squid hydrolysate we call squid juice. So,
all right. Yeah, thanks, Sammy, and thanks to the Organic Council of Ontario for giving this opportunity to share about this emerging biostimulant. So, just trying to, yeah, there we go.
And in the meantime, when you're getting set up, Av, everyone feel free to text any questions in the chat, and we'll make sure to answer them at the end of the presentation. It should be about 20 to 30 minutes, so thank you.
Perfect. Great. Yeah, so in this presentation where I want to kind of focus on, we're going to jump in and talk a little bit about what are biostimulants. And of course, the focus of this talk is to talk more about squid hydrolysate in particular. And then I might invite Sammy back on and we'll talk a little bit more about some practical applications of using squid juice. So, to start with, biostimulants, probably many of you are using biostimulants, and many of you probably have used them for years. Biostimulants have been around for thousands and thousands of years in agriculture. Yet the term biostimulants has only been used, I think it probably came into production in about 30 years ago. And so I think the real rise in biostimulants is now coming because there's this increased understanding that the plant is not in isolation. So oftentimes in mainstream agronomy, we treated the plant as an individual. It did not see it as part of an ecosystem. As we've learned more about the microbiome, learned more about the phyllosphere and the rhizosphere, we start understanding that the plant is in fact an ecosystem in itself. We've referred to the rhizosphere as the second genome of the plant. When we start understanding that, then we can actually look at some of these products that have been used for thousands of years and understand that they are having impact on the plant, although they may not have direct fertility impact. And that's really what biostimulants are. So these are a couple of definitions, and the definitions of biostimulants are evolving. In this first definition, I think what's really important is that it highlights how biostimulants do not provide direct nutrition to the plants. Instead, they act as catalysts, enhancing the plant's natural processes. That first definition also highlights the fact that microorganisms, it's not just substances and byproducts of other industries that are considered biostimulants, but it's in fact microorganisms as well. The second definition, what I liked in that definition, is that it highlights the fact that many of the biostimulants that are used are used at low doses. And so as opposed to what we see as when we're using fertilizers, where we may be actively putting on hundreds of pounds per acre, a biostimulant is used at a far lower rate and in conjunction with your existing farming practices. My first, I guess, knowledge that I was using a biostimulant or that a biostimulant was being used was about 35 years ago when I met with an organic apple orchard farmer. And that orchardist would always use some fermented fish That was his way of addressing bitter pit. Bitter pit is an expression of low calcium in apples, and so I looked at the soil analysis, and I looked at the fermented fish analysis, and there was actually no it was inadequate levels of calcium in both, and yet he didn't face bitter pit, and he said this helps me get calcium. So that was my first understanding of what a biostimulant can actually do. If we look at the world of biostimulants, and it is a ever emerging world, biostimulants are probably the highest, fastest growing sector within the agricultural input. They will reach the billions in a few years in sales. And the largest one is actually humic substances. So when we look at the top part of this chart, we see that the acids, humic and fulvic acids, humans, as well as amino acids, B vitamins, which are actually really high in things like kelp and seaweed extracts, but those form a big portion of some of the biostimulants. Definitely an emerging sector is the microbials. As we learn more about things like the rhizosphere and plant growth promoting rhizobacteria, we start learning a little bit more about how we can use these to our benefits. And so now you're seeing more and more products, the fungal products like mycorrhizae and trichoderma, and still the old standards, the ones that we probably have used in the past, things like rhizobium for those of us who grow legumes. What's particular, the probably next to humic substances, the next biggest category of biostimulants are the extracts, and in particular seaweed-based extracts. Many of us have probably used a kelp extract of Ascophyllum nodosum, but there's other extracts. Some of us might actually try to do our own fermented extracts, like some of our plant teas. But there's other things, and one I want to highlight that we'll be talking more about later are peptides, which is a big component of what we're going to be talking about, and one in particular, the chitin or chitosan. And so those are other major biostimulants that we're going to be talking about. And the last sector is the last circle there represents the other category, and in that, this is where squid hydrolysate fits in, right? So it's a protein hydrolysate, but it is an emerging and ever evolving sector, right? So we're starting to see things like many trace minerals being included. Silicon, for example, is now considered a biostimulant. It's not an essential element, and it doesn't necessarily work like a fertilizer in terms of increasing plant growth or plant yield, but it does work in terms of an immune response. So that's another example of what a biostimulant can be. As I just mentioned, some of the types, the main types that I want to talk about, humic acids. Most of it is derived from brown coal or leonardite. Humic acids, fulvic acids, humans, they all improve soil structure. They work as a great chelator, so they can enhance nutrient uptake by holding on to a lot of cations in particular, but as well as anions. They can hold on to those until the plant needs to use them. And many of you might use humic acid in your early starts, just because it can stimulate good root development. The next largest group of sales in biostimulants are our seaweed extracts. As I mentioned, they're really high in B vitamins. They also have some amino acids, but they're incredibly high in trace minerals and micronutrients. Most seaweed extracts are basic polysaccharides, so a sugar, but often are being used because we've seen that using a biostimulant, seaweed-based biostimulant, we can reduce stresses. In particular, stresses like cold stress, heat stress, drought stress are often mitigated by the use of something like a kelp extract. The main group that we're going to talk about today, of course, are the protein hydrolysates, in which squid hydrolysate is part of. Most of them are actually derived through chemical hydrolysis. So about 90% of what you see on the market in terms of protein hydrolysates are in fact chemical hydrolysis, which squid hydrolysate is actually, or squid juice is actually done through an enzymatic hydrolysis. So you incorporate an enzyme, and that enzyme helps break down that material to make it into its forms of mainly peptides, polypeptides, oligopeptides, and amino acids. Protein hydrolysates can either be from animals and or plant. Of course, the emerging market, as well as the beneficial microorganisms, it can be as basic as using compost or doing compost teas. But on the market right now, you're going to see some very specific, we call them bugs in a jug. Essentially, you get a few species which are known to do specific things like increase nutrient cycling, perhaps making elements like phosphorus or iron more available to the plant. And many of them also will have some good antibiotic features as well, and increase the immune response within the plant. And one that I had mentioned earlier that we will talk in greater detail is, of course, chitosan. Chitosan is the deacetylated, so you remove an acetyl group from chitin, and chitin is a polymer that's found in mollusks like squid, as well as in crustaceans, and through other products as well, you can get chitin. But chitin or chitosan can stimulate the plant defense mechanisms within plants, so therefore they get a higher immunity. They start producing a lot of secondary metabolites, which are usually why we like to consume a lot of products. If food is going to be our medicine, we want a lot of these secondary metabolites because they're the ones that are the antioxidants, the vitamins, and so on. So those are the main groups. So how do they work? When we think of plants in nature, they're always being exposed to a lot of stresses, right? So whether it's at this time of year, very easily cold stress can wipe out a crop, or in the case you left your greenhouse shut and it went from a cloudy day to a sunny day, all of a sudden you've got a lot of heat stress happening. Out in the fields, we can have a lot of drought stress. We can have salinity issues, heavy metal issues. All of these things can affect the osmotic potential around that root system, and cause a lot of those stresses that will impact growth. Biostimulants, unlike fertilizers, they're not there to necessarily help the plant grow by providing the essential elements for growth. Instead, they may help processes within that plant to then fight off some of these stresses. We'll get into more details, but for example, something like a seaweed extract, which we know has high levels of potassium, but also has some phytohormones. Those phytohormones and the potassium can help stomatoregulation, right? So it's regulating the stomates on the leaf, which can help maintain regulate the gas exchange, and therefore allow the plant to not transpire as much or to increase transpiration, and therefore have a better ability to fight some of the stresses that they might be facing. Some of the benefits of biostimulants is, of course, one of the things, the main thing we want is to enhance our crop yield. We want to increase our growth. And largely that's done by increasing nutrient uptake. So The main reason many of us want to use biostimulants is that we get increased uptake of our nutrients. If we're using a lot of soluble fertilizers or plant available fertilizers, what biostimulants do is help the plant take those up in greater amounts. Secondary, of course, is the enhancing the stress tolerance of the plant, which then can lead to increased quality, not only because the plant is not subjected to those stresses, but also that some of the factors that the plant uses to fight stress can improve the quality of the crop. Many of the biostimulants that I've mentioned before, like humic acid, chitosan, they in fact will, and of course the beneficial microbes, they can in fact increase the soil, enhance the soil structure, right? So we're starting to see people using biostimulants because they will enhance that soil structure, and thereby the plant has greater opportunity to increase their nutrient uptake. You're getting better root growth. More root growth also translates to increased nutrient uptake, and oftentimes relates to the plant health and the vigor. One of the real reasons why it is important to be kind of adopting biostimulants into your practices is that it will help you reduce your reliance on external input, other external inputs, and in this case, chemical inputs. So there's been a rapid adoption of the use of biostimulants by the conventional agriculture, in large part because it means that they can use less chemical fertilizers and they can use less pesticides. And this really ties back into increased nutrient uptake and increased stress tolerance, right? As you increase your stress tolerance, plants aren't subjected to pests and pathogens at the same degree because they're already at a heightened level of plant immunity. And also in terms of stress tolerances, like as simple as things like transplant shock, right? That's a stress. Beneficial microorganisms can really help reduce that stress tolerance. And other biostimulants can do that by addressing certain mechanisms within the plant that turn them off, and so therefore the plant is all of a sudden told, hey, it's okay to grow, and they continue to. Some of the applications of biostimulants, this really shows the evolution of biostimulants and the fact that it is going to continue to evolve. There's innovative farmers out there that are going to use biostimulants in various ways to work in with their existing farming practices. One of the ways that I really have looked to see where biostimulants might emerge as a lead would be in the seed treatment sector. We all know about using certain fungicides. It really does not make a lot of sense to use fungicides as a seed treatment, considering that seed coat is full of all of these beneficial bacteria that are so important to becoming endophytic, entering into the plant and being beneficial to that plant. If you use a fungicide as a seed treatment, you're essentially killing off all the beneficial bacteria, which is sort of like killing all the beneficial bacteria that we have in our own guts, and then expecting us to be able to be a healthy human. So looking at biostimulants, whether it's beneficial microbes or things like humic acid, squid hydrolysate, these can be work well as seed treatments. Foliar application. Many of you probably use foliar applications to get some nutrients onto your plants. The benefit of using a biostimulant like a fulvic acid or like a squid hydrolysate is you're going to get increased nutrient uptake. We've now started to understand the benefit of the phylosphere. So the phylosphere really represents the microorganisms that are on the leaf surface. Many of those microorganisms on the leaf surface are there to help the immunity of the plant, but also to incorporate nutrients. And so you can use biostimulants to help things like improving the stress tolerance, as well as taking up nutrients better. The majority of biostimulants are probably used as a soil applicant. So a soil drench is probably the best way of incorporating a lot of biostimulants. And as one of the main reasons why I think biostimulants are so important is that you're going to increase your photosynthetic ability. Nothing can improve soil structure better than having optimizing your photosynthesis. So if you can capture as much of that sunlight, have that sunlight and the chlorophyll work together to somehow produce some glucose, putting that glucose, those exudates into the soil, that's what truly will increase the soil structure, and that's one of the real benefits of using something like a biostimulant like squid hydrolysate. And then, as I mentioned earlier, it's so important that we recognize that biostimulants should not have to be something that really takes you away from your existing practices. Many of you may use soluble nutrient solutions in your greenhouses or even your field crops. Just adding a biostimulant into your fertigation system is a good way of increasing plant growth. There are some considerations that I wanted to bring to your attention. Biostimulants have, despite the fact that biostimulants are relatively ill-defined, right? Many of them have multiple ingredients, multiple active ingredients, and that's probably why the mainstream agriculture tried to dismiss them, is that they could not define them as, you use this to get this result. But at the same time, we want to make sure that we don't use the wrong biostimulant for a particular outcome. And one of the benefits that I see in using something like a squid hydrolysate is that it encompasses quite a bit, but because you know what its main goals are, you can choose to use it appropriately so that you're not in any way causing any phytotoxicity or detriment to the plant, right? So one of the other things that ties into the application and timing is that you don't want to overuse a biostimulant, because one of the challenges with that is that every time you're doing that, you are triggering something within that plant. You may be changing some of the hormonal fluxes within that plant, and all of this will require some energy. And so if you're using it too often, you may end up causing decreases in the plant's growth because it's expending a lot of energy reacting to the biostimulant. And that can be expressed also as a phytotoxicity. If you have, for example, even with something like an amino acid, your plants can take up too many amino acids, and that can be damaging to the plant. Integration with current practices. This is how I really want to see biostimulants being used, is that it just slips right into your existing practices. Very few of us have extra money to just spend on inputs. So what I typically recommend is that we just do an exchange. Depending on how much you're spending per acre, you just simply reduce that by the amount of the cost of the biostimulant. If you targeted the right biostimulant for what you're using, then it should just cost the same, and hopefully you get a greater return on investment. And I think the current generation of farmers, more so than any previous, is really focused around sustainability issues. And it's kind of nice to question all of our inputs and making sure that our inputs are coming from the most sustainable sources that possible. And that's another consideration I think we should look at. So our main target was to talk about protein hydrolysates. And as I mentioned, they can be either chemical or enzymatic hydrolysis of animal proteins. Predominantly, we see fish, occasionally some whey, and in this case, squid. And then in plant-based ones, we might see things like soy hydrolysate or an alfalfa hydrolysate. Corn is also becoming one that's a lot of people are gaining some interest around. For the most part, protein hydrolysates are a mix of soluble peptides, as I mentioned, oligopeptides, polypeptides, and amino acids, all of which are readily taken up by plant roots and leaves. So there was a time that we felt like only elements and simple cations and anions were the ones that could be taken up into a plant's roots or a plant's leaves. We now understand that plants can in fact take up whole organisms like bacteria and fungi, as well as taking in amino acids, some proteins, and peptides. Protein hydrolysates are predominantly the two main reasons we like using them is one, of course, for the increased uptake of macro and micronutrients, and secondly is for the increased tolerance to stresses. So let's talk about squid juice. So squid juice increases, and some of this Sammy mentioned in the intro, but it increases the plant uptake and transport of amino acids and peptides, and which are kind of the foundations to primary metabolites as well as secondary metabolites. And by secondary metabolites, I'm referring to increases in things like flavonoids, antioxidants, and terpenoids, a whole class of secondary metabolites. And once again, these are the things that we want when we want to consume that tomato with a high level of lycopene, or we want our red wine to have resveratrol, or we want our carrots to have carotene. Those are all secondary metabolites, and those are the things that give us health. And so that's what some of these biostimulants do. Squid juice in particular actually has a high level of L-methionine, and this is the amino acid that can open up calcium channels in plant roots, right? So through this, using squid juice, you could see a reduction in things like blossom end rot, right? So blossom end rot affecting tomatoes and eggplant, peppers, is a calcium deficiency. Cavity spot in carrots, a calcium deficiency. Tip burn in lettuce, black heart in celery, and even I mentioned here cat face in strawberries. Probably a boron deficiency, but calcium really drives the uptake of so many other nutrients as well, right? If you have calcium entering into the plant, you're also carrying a whole bunch of other nutrients with that. And that's what having L-methionine in squid juice can help too. It also, if you're familiar with the amino acid L-tryptophan, it is a precursor to so many phytohormones and other biomolecules. It is a precursor to indolic acetic acid, which is an auxin, and as you know, auxins are the hormone that really targets growth, but also it's a precursor to gibberellic acid, as well as ABA, or acetylbutyric acid. Both of them are also phytohormones. Gibberellic acid really helps with germination and cell differentiation, and acetylbutyric acid, lot of times is used as a good rooting hormone. So you're going to see good root growth. And speaking of root growth, L-tryptophan also helps modulate things like cytokinin and melatonin as well, right? So melatonin, very important in stress tolerance in plants as well. I tend to focus a lot on the amino acids that are in squid hydrolysate, but it's also important to know that there are those peptides, and we're just starting to learn more and more about peptides as biostimulants. We really didn't picture them as something that's really important for plant health, but we're understanding that many peptides have the same function as signaling molecules. So they're almost working at hormones, and they can do a lot of regulation within the plant. So I would expect as I mentioned earlier, a lot of uh, biostimulants, people are starting to extract a particular ingredient within a biostimulant, and then expanding that and making that a product. I would imagine, I think there's over 20 different peptides that are being used um, as biostimulants within the plant world, and I expect that to expand quite considerably as we start to learn more about them. I personally, I love the aspect that there's a lot of magic in the sense mysticism. We don't know exactly what is working when we use a lot of these biostimulants, and I kind of like that mystery. What makes squid juice different? Well, as I mentioned before, the sustainability, and Sammy mentioned this in the intro, it is a byproduct of calamari production. So, unlike a lot of fish hydrolysates that use whatever they catch in their nets, and make that into a product, squid juice is made as benefiting from the waste product of calamari production. So instead of that just being um, uh, used as waste, it is just upcycled into a biostimulant. Squid juice is approved for organic use. It is enzymatically produced. So the phosphoric acid is just used for stabilization, very common in a lot of organic soluble nutrients that to give it some good shelf life. And arguably, the shelf life of squid juice is, I just learned, is incredibly long. And then there's some organic soluble potash. So you have a 222 NPK analysis. But as I never really emphasize the fertility of squid juice or most hydrolysates, I kind of look at the biostimulant factor. But it's also important that it also has a lot of trace minerals as well. I've mentioned this before, is that squid juice is manufactured through enzymatic hydrolysis and at low temperatures. And the real benefit of that is that it allows those amino acids to remain in a biologically active state, right? So when we say something like L-tryptophan versus D-tryptophan, both of them are an amino acid. They're an isoform. Essentially, they've been flipped. The L form is biologically active. That means it can be taken up readily by the plant just as it is. The D isoform is not taken up by the plant. It would have to be broken down by microbes and then reformulated into a particular amino acid. And really what makes squid juice so different than a lot of other hydrolysates, protein hydrolysates, is the fact that it contains chitin. And not only does it contain chitin, it contains both forms of chitin, alpha and a beta, or chitin A and B. And that is, can't remember which one, but one of them is actually more readily soluble. Chitin in itself is not a soluble polymer, but it can be more soluble the one that is extracted from squids. So that's one of the real benefits. And as we learn in so many ways, chitin or chitosan, and chitosan is the deacetylated, so removing that acetyl group. It can help induce callus formation. So if you're doing some, cuttings or clones, looking for increased, quicker root formation, chitosan can help with that. Chitosan is a proteinase inhibitor, so that really prevents viruses from replicating. It helps produce phytoalexins that help the plant control and a defense mechanism. When applied as a foliar, it can regulate the stomates. That's what gives it that ability to survive under drought conditions. Also cold tolerance as well through that. As I mentioned before, chitosan seed treatment, a great idea because the proline and the sugar can help increase seed membrane permeability, so you get quicker water imbibition. Chitosan improves the activity of several enzymes. Chitosan acts as an antifungal, antiviral, a bionematicidal. So that's one of the main reasons people were interested in learning more about how you can use chitin or chitosan, is that when it's prevalent around the roots, if you have root feeding nematodes, it can deter that. And so, something like squid juice with a very soluble form of chitosan, it's present all around those roots, and then it can fight off any nematodes, especially the root feeding nematodes. And of course, chitosan acts as a carrier as well. It's a chelator, and so that allows for increased plant availability of nutrients. And because it's a chelator, it's also a good way of tying up heavy metals, and it in fact becomes a nice little home for microbes as well. So just summarize there, squid juice as a biostimulant. I want to emphasize the less is more. This is probably not a great marketing thing for Seaborn Organics, but it, the idea of less is more really is so important in biostimulants. Many of them are probably what I would consider biphasic. So if you use too much of them, you almost get the inverse response, right? So it's important that less of the product can actually create a good enzymatic reaction, or a good catalyst for those reactions. The application rate is quite small. It's 1 gallon per acre. It can be applied weekly with most crops, with no worries of phytotoxicity or sort of amino acid uptake into too great of an increase of amino acids. But even at using it 1 to 3 times during a crop cycle, you can still see observable results, right? So for those who are just new to trying it and are skeptical, just trying it 1 to 3 times, and you will see noticeable differences. The synergistic and complementary benefits of biostimulants with other fertilizers and biostimulants is somewhat unknown. And that's kind of what's interesting, is that I look to the future where I can see squid juice being combined with humic acids and with a kelp extract, and seeing what the potential of those will be as well. I just threw this in because it just shows. I mean, Seaborn is doing some trials, and this was a trial that was done in California, looking at squid juice as a fertilizer source, right? Like I mentioned, it has an NPK of 222, and what I noticed from looking at this trial is that yes, it can work well as a fertilizer. It can produce higher yields, and it can produce better quality. So you're seeing more ears per corn. You're seeing a greater diameter with the ear. Pollination set was somewhat confounded in this trial, but that may also speak to the fact that really, in my opinion, squid juice should be used better as a biostimulant than a sole fertilizer. If the trial is done in where you're using your existing fertilizer program, and then you add to it something like squid juice, I think that's where we're really going to see our real benefits. So just to sum up, I think the whole idea that many of these biostimulants that we're using, and in particular squid juice, they are upcycling our waste systems, and so instead of losing these products, we're in fact being able to repurpose them to have tremendous environmental and economical benefits, right? So we're reducing our need for chemical fertilizers, reducing our need for pesticides, because these biostimulants can help improve those uptake of those nutrients, can elicit the particular responses within the plant to trigger a higher immunity, and therefore reducing the need for things like insecticides and fungicides. So just in summary, squid juice is a novel product offering more biostimulant properties than most protein hydrolysates. And that's in large part because of the chitin, that chitinase or the chitosan is really integral in terms of getting that plant immunity heightened. And then the particular way that squid juice is produced to ensure that you still have biologically available amino acids and peptides makes it a far superior product, really allowing for that uptake of those products. And I think that's where I am finishing up here. So I do invite Sammy to jump back on and maybe share a little bit. I should.
Absolutely. Can you hear me all right?
Yes.
Fantastic. Yeah, thank you, Av. That was a very informative presentation, and you did a great job of encompassing the wide range of benefits that squid juice has to offer. Very in-depth product from not only diverse nutritional profile of a 222, but almost 1% calcium. We've got magnesium, iron, sulfur, boron, copper, iodine, and the list goes on. But our biggest differentiator is definitely the chitosan that you mentioned, and the long list of benefits that we saw on the slide. So great job, and thank you very much. I want to open up the floor for any questions. We'll stick around for a minute or two if anybody would like to pick Av's brain. I know you guys hear lots from me, and this is a great opportunity to ask some more in-depth questions. And we're also open to more specific questions as well. If you've got anything that's relating directly to your farm or applications of use, we're happy to discuss that. And I think you did a great job of it can really be used throughout the whole life cycle of the plant. So it can be utilized in many different ways. And that we like to say it's a simple solution to introduce to your formula as an additive, whether that's in the soil or as a foliar to really help support your crop and soil health. All right, let me check the chat here. I don't think we have any burning questions that I see.
Can I pipe in?
Yes, absolutely. Please do.
Yeah, so I was going to ask a question as far as knowing that you guys have the beta form of chitin, I would like to complement it with the alpha form. I'm kind of curious your opinions on rates that we don't overdo things and have a reverse effect.
Yeah. Okay. So I mean, I can Sammy, feel free to jump in. So at the application rate that's being recommended, the only times that I would be most cautious about is in probably early flowering of any plant. Just to make sure that the stresses aren't too significant to cause any stresses, heightened stress at that point. But following that, once you sort of get through some initial flowering phase, that's when I feel a little bit more comfortable that you can continue to adding it at its recommended rate of, if it is 1 gallon per acre. Is that
Yeah, correct. We suggest 1 gallon as an additive per acre or 2 gallons as a standalone, and that's a low enough dosage and application instructions that we're very confident that there's not going to be any negative impacts to your plant.
And it might, for example, with some cannabis producers, that's typically the time that I would be most cautious, is that early flowering, just because that's when you could get some hermaphrodism expressed through having too much chitin.
I hope that answers your question. And to add on to that, I definitely think that there's room for both A and B biostimulants, and they both offer their own unique benefits, right? The A form of biostimulants is typically found in crab shells, shrimp shells, fungi, and insect frass. And it's typically a more non-water soluble, a long-lasting play, whereas ours would be a more instant uptake. And I think it's a great opportunity to potentially combine the two for a 1-2 punch. Is that fair to say, Av?
I think my understanding was that squid juice had both the alpha and the beta. Because it I think the squid would. I'm not necessarily sure if the parts that are being used would be.
Yeah, so the main source of chitin, which is a B form found chitin, is in the pen of the squid. That is what's protecting the internal organs of the squid, and that's a soft tissue base, and is why it's more associated in a B form of chitin, because it's not a hard external shell such as the other ones. But I definitely could think that there would be a combination.
I'll have to, yeah, I'll look that up as well.
Sounds great. We've got another question here. Where are the squids sourced from, and is it sourced for a specific use? So we source our squid from calamari processing off the east coast of Canada and the US. So it's a byproduct of calamari processing. They use the Liligo squid for calamari, and people don't realize that over 52% of the squid is regarded as waste. So we take that 52%, and instead of it going into landfills or back into the ocean, we're repurposing it and into our hydrolysate formula. Can they get a copy of the slides? They'd like to know, Av.
Oh yeah, by all means. Yep.
Okay, wonderful.
Through you, I'll send it to you. And
sounds great. We'll make sure to post it on Facebook and Instagram and other social medias. And eventually we are going to have this presentation available on our website as well. We are recording it. I'm glad you got your answer. Thank you, Tiffany. Okay, I'm just scrolling through the chat. I think that's all the questions that I see here. So yeah, I just wanted to thank everybody for giving us their time and attention tonight. We really appreciate your support, and we really pride ourselves in being an ethically sourced and sustainably sourced product, and not only supporting regenerative and organic farmers, but really bridging the gap from synthetic farmers as well, helping them reduce inputs and really have an emphasis on soil health and taking care of that soil, which will then compound into better crops and better environment, more nutritious food, and lots of positive outcomes. So yeah, thank you everybody for being a part of a positive change, and feel free to contact us on our website if you have any more questions. And thank you so much, Av, for
thanks,
being
Sammy.
here and sharing the information that you do. You're a plethora of knowledge, and we're really happy to be working with you.
Likewise, right back at you. Thanks so much.
Okay. Have a great night, guys. Bye. Thank you. Thank you. Good night.